Hey everyone, my name is Usman. I'm a developer relations engineer here at Alchemy. And if you're like me, you've probably been seeing x402 all over your social media feed this week. It's been blowing up everywhere. And I wanted to dive in for myself and see what 402 was, what it enables, actually get my hands dirty and build something with it. So I want to showcase with you guys what I ended up learning, what I ended up building, and how you guys can use what I've built to build something of your own. So super excited to jump into this and learn a little bit about 402 with you guys. So before we jump into any sort of code or what we built, the easiest way to think about X402 is that it enables any sort of user to be able to pay for API resources without any sort of authentication like registration or email or like OAuth or traditional things like API keys. And the idea is that these resources are all being facilitated by USDC on Base. But you're probably thinking what I'm thinking, which is why wouldn't a user just create a account with whatever platform that they're trying to get resources from and get their API key themselves and just get data from their API key? Well, the ideal user that X402 is geared towards is actually a new type of user that we haven't interacted with too much in the crypto space, which is agents. And the idea is that if an agent wants to come in, query some data, let's say they want to make an API call, in order to make an API call, they have to pay the provider of that API, let's say 1 USDC, to be able to get whatever resource that they're looking for. The idea is, though, that these agents wouldn't be able to go to whatever platform like Alchemy or like OpenAI to grab that API key and create an account and go through that whole process. They're going to want to query data, they're going to want to query it fast, and they're going to want to go to different data providers, different APIs, and they're going to want to be able to pay for it on a per query basis. And that's for where X402 comes in, and that's what it enables. So this segues perfectly into what it is that we ended up building. So when I learned a little bit more about what 402 was, it got me thinking, what data is it really that agents are going to want to query? What APIs are these agents really going to want to ping on a consistent basis? And obviously there's a tons of different APIs out there. We're seeing agents be able to do so many different things nowadays. But in the on-chain world, blockchain data is probably one of the most important resources and commodities. And it's only going to be more important for these agents as they start to get into things like trading, or they start creating these more sophisticated bots that need access to real-time data to be able to make sophisticated decisions. Blockchain data is going to be huge for them. And they're going to be needing to query that data on a very consistent basis. So imagine if we had an API that was kind of like a vending machine where you could insert a payment and get instant access to whatever data that you want, whatever blockchain data that you want. And that's essentially what Vend is. It's a monetizable blockchain data API via X402 and Alchemy, where you can get blockchain data on demand like a vending machine. So let's dump into how it works. So getting a little bit underneath the hood of Vend, at its core layer is a Express.js server that is integrated with 402 that wraps some of the most essential blockchain data APIs that are most standardized and used throughout the industry, things like transaction history, data API, and token balance, where users are able to query these via the client, as well as create webhooks for real-time notifications for things like new transactions straight from the client. And the cool thing is that they're able to do all these functionalities after they have paid via the facilitation of payment of X402 and USDC on Base. So that's Vend at its core layer. Also built a very simple CLI so that we can interact with it one layer above. It makes it very simple so we can just hit some commands, get access to whatever data it is we want, and test Vend in a more succinct way. But the ideal audience for Vend, which is agents, they would be interacting with the client, just pinging the server directly. So before we jump into actually showcasing the code and how Vend works, this is a little bit more of a diagram that illustrates the flow. So let's say a user makes an API request. Let's say they want to find out the NFTs of a given address. They're going to make that API request. What Vend is going to respond back is a 402 payment required statement that essentially says that, hey, in order to access this data that you're requesting, you have to pay this amount of USDC to this address. Now, for that user, they're going to pay that USDC. Once they have paid, they have to return a payment hash, or almost like a receipt, back to the API. Vend is now going to take that receipt, verify that payment on-chain via Alchemy's on-chain verification package, and then it's going to also query Alchemy for that data and then return that data back to the individual once it has verified that they've paid. And that's just a very simple flow of how Vend works and how you can pay for queries on different pieces of data. Now let's jump into actually seeing how it works in real time. So what I did here is I just cloned a fresh Vend repo straight from GitHub, almost directly as if anyone was doing it the identical way. So what I'm going to do here is all you have to do to get Vend started and to be able to interact with it directly and straight out of the box is just come over here, add your own personal Alchemy API key as well as the recipient address for the payments that you'd like to receive payments at. So I'm just going to go ahead and copy and paste that over here. And then all you got to do from there is just go ahead and install your dependencies and you're good to go. So now that we got our dependencies installed, let's go ahead and start our server. And you can see that when Vend initializes, what it does is it actually kicks off two different instances of Alchemy, where you're initializing the Ethereum mainnet network as the network that we're going to be querying the data from, as well as you're initializing the network that you're going to be facilitating payments on, which in this case is Base. And you can see that the Vend server is started, so now we can go ahead and interact with this platform. So moving into our terminal here, let's go ahead and try an API request to Vend and see if it returns us some data. So let's say we send a simple curl request to see all the given transfers in this address. Oh, that's weird. I'm getting an error message that says payment required, status 402. And what essentially this is that it's telling me that I need to pay to be able to access this data. I just made a simple curl request like I would as a traditional API, but if I don't pay for it, it's going to give me an error that says 402 payment required. And it's going to tell me how much USDC I need to pay, obviously the currency, what network it's going to be on, and where that payment needs to go. So that's 402 in action right there. So now imagine if I actually inputted a transaction hash. Right now I'm just going to use a demo flag for the sake of this demo, but in a real world scenario, you just input a real transaction hash with the header, X payment hash, make the same curl, put in your transaction hash of that paid amount, and then you go ahead and retrieve whatever data that you want. So the magic here really is that there is a flag of payment hash, right? And once you input that correct payment hash, Alchemy is going to verify that data that you actually sent that amount and then retrieve you whatever data that you're looking for. So you can see that's exactly what happened here. And essentially this is a pay gated API where you're paying a small amount to be able to query that data. And this is where agents would be able to do so. So what happened here is that there were two total API calls per this request. You had one, which was the payment verification. That was get transaction receipt on Base, which validated that the payment was actually completed. And then we had the data query, right? We actually used get asset transfers to be able to return that this data that was requested. So that was essentially two Alchemy API calls per request. And you can really start to think about, hey, the economic model of building a business sustainably on top of something like this, where your cost is X and you're charging Y to be able to facilitate this data to agents. Awesome. So what we're going to jump into now is the Vend CLI. So what the Vend CLI is, just a more easy way to interact with Vend. So we built this little command line interface with a couple of different commands to be able to hit those APIs and interact with the data in a bit of an easier UX. But obviously for the main audience of this technology is agents, they would be interacting with the client directly. But for users like yourself and myself, we can interact with the CLI in a bit of an easier way. So for example, if we were to ping one of these commands, let's say we wanted to query all the transfers that are taking place under a given address, and we pass through our receipt that we ended up paying for it. So you can see that now it's going to query the 402 API, which is going to check the payment. Then you can also see that, boom, this wallet has all these different tokens underneath it. And that's just being able to interact with it directly from the CLI. Now, another really cool thing that Vend in general does is that it allows agents to be able to create webhooks. So if an agent wanted to create a webhook that monitored the different ERC20s or ERC721s that, let's say, Vitalik was trading, it would be able to essentially use Alchemy's Notify API through Vend, which would allow it to listen for these movements of tokens that are taking place. So you can kind of see here, we create that command and then boom, webhook created successfully, right? So now you can kind of see that we have a new webhook that was created where now, if we wanted to see that, it's essentially listening at this address to see when those token transfers are taking place. And you can imagine an agent who needs real-time access to certain pieces of data, especially one that's maybe, let's say, tracking whales or things of that nature. It would be able to query this data on its own, pay for it, and have instant access to it on a given basis. So one other thing I want to showcase is now, like, what can you actually build with something like Vend on top of 402 and on top of a data API? The reason I held this off to the end was to kind of showcase to you the hands-on flow of what it is that it looks like when you're building with something like Vend. So we'll walk through it one last time, visually kind of depicted to us, where if we make a client request, an agent makes a client request to get some data from the API, they're going to be returned with some instructions to be able to pay the address whatever given amount. So let's say they go ahead and make their payment, boom, they get their transaction hash of that receipt. Now they go ahead and send the client that receipt, letting them know with the payment flag that, hey, we actually ended up paying them. And once that payment is confirmed and verified, they get their data back, and that agent is able to do whatever it needs to do. That's the flow that we walked through already today. Now imagine in a use case where we had agents that are programmatically buying services from each other autonomously, where we have one agent that is selling data, we have another agent that is buying data, and those agents are able to walk through this exact process that we just discussed, right? And essentially end up in a situation where we have two different agents who never met each other, no pre-existing relationship. They don't have API keys shared with each other or shared with each other. They're able to execute a transaction where both agents get exactly what they need, where one agent gets the data that they were looking for, and one agent gets the payment that they were looking to get for that data. And this can repeat infinitely. And imagine when we have a world where we have thousands and thousands of different agents, where we have agents like Vend that are facilitating data, we have analytics agents that are buying that data, we have trading agents that are also buying and selling data, and so on and so forth, where this is kind of the flow that is going to be able to power that. And then you can really see at the scale where X402 becomes this massive, massive opportunity to be able to build in. So that's a little bit about X402. That's a little bit about Vend in general. Feel free to dive deeper into the documentation. There's a lot of different things here that teach you how to deploy to mainnet. And one other thing I want to shout out here is that Vend uses the X402 on-chain verification package, which is a package that I built that is a little bit different way of verifying the transactions on-chain, where Coinbase uses a facilitator model. On-chain verification directly verifies the transactions on-chain via Alchemy's APIs. It's able to read the blockchain and see that this transaction actually took place. And it's just a little bit of a more preferred way on my side to be able to do this. So I just released this package. It's fully open source. You can use this in any Express.js API that you're wrapping with 402. So yeah, super excited. Hopefully this was helpful. Reach out to me if you guys have any questions. I'm going to be building more different stuff in the 402 space. So excited to see what everyone else is building, and excited to continue seeing the proliferation of 402. Thanks all.